Hi, do you have a wall adapter or power supply that doesn't output right? It turns on and off or can't maintain its voltage? It's likely the damn electrolytic capacitor in it. If you have watched my videos, you know electrolytic capacitors can blow with a Oh, they have to be connected to a circuit to blow up, but they don't always blow up. I want to see what happens to them when they half break. Let's half break one. Okay, I have a tiny electrolytic capacitor and I'll half break it in an accelerated fashion by connecting 120 volt AC across it. Don't try this experiment. These capacitors typically half break over a lifetime of usage, but I don't have that kind of time, so I'll over voltage it until it half breaks. Just a quick touch. Well, this is a very familiar mode of failure around this neighborhood, where excess overload results in capacitor elimination. This is a total failure. When I say half failure, I mean the capacitor still capacits, but it is capaciting at half its capacity. Capacit is not a verb. It's like when you add or to a verb. Inductor inducts, collector collects, mentor ments. Ment is not a word. When I hired you as my writer, I thought you could English. I can English just fine! Anyway, a halved capacitor still works, but halvely. Let me draw this for you. A capacitor is made of two conductor plates side by side, separated by a non-conductive isolating layer called a dielectric, and charges are stored on its plates. The wirings inside a capacitor have their own resistances, we show as a very small equivalent series resistance or ESR. Also, even the best dielectrics can leak very little current that we can show as a super large resistance. We always ignore it's so large, like giga-ohms. And then we have polarized capacitors like electrolytics that the dielectric is such that it acts like sort of a diode. I explained all these in my video about capacitors, but any part of a capacitor can degrade, causing a less capaciting capacitor. It's not a word! I have a brand new 60 volt 40 amp power supply and my capacitor is rated for 16 volts, but I place it in reverse polarity, and if I increase the voltage, at some point it starts conducting current and the capacitor will slowly heat up. You see? Oh, there you go. It's starting to conduct. It's almost 1 watt through the capacitor. Oh, I didn't even see it bulging. I guess it's like a pressure cooker. The dielectric gel in these electrolytic capacitors boils and the pressure builds up until it blows up. I just want to half break a capacitor. I guess I have to let it cook slowly, so I just give it enough voltage for a little bit of current so that it doesn't blow right away, and I just put it on the side and let it get damaged over time. Now, while the cap is cooking, did you see Elon Musk's latest announcement that a person with Neuralink's brain implant can move a computer mouse with their thoughts? Is that good or bad? To understand it better, I used articles from my sponsor Ground News. This platform was created by a former NASA engineer. They collect news articles on any topic from all around the world, so you can compare coverage in a scientific, data-driven way to get the full picture. Check them out at ground.news/ElectroBOOM. On this subject, they have over 150 articles, so we can see a spectrum of reactions. One calls it Nobel Prize worthy, while the other worries about the risks of having a chip in the brain. Not only can you get the information from all sources, but also Ground News reports on where they stand on the political spectrum. This makes Ground News such a valuable service because knowing the existing biases in articles makes it easier to get to the truth and avoid censorship and misinformation, which is why I'm a fan of Ground News. And there you can also follow your interest for the latest updates. I use the Vantage subscription for unlimited access, which you can get at 40% off using my link, if it wasn't cheap enough already. Or try their starter plan for just $1 this month and keep yourself well informed and support a team who's working to make the media more transparent. It should be well cooked. Oh, shit! You know, the issue with tiny capacitors is they don't have pressure release mechanisms, but the bigger power capacitors have it, because the explosion can be catastrophic. So they have, for example, these tiny grooves on the top plate. This is a healthy 2200 microfarad capacitor with an ESR of around 0.1 ohms and the parallel resistance is over 6 mega ohms. So when I overload the capacitor and it bulges, those tiny grooves on the top break open, allowing the release of the pressurized gases, and this will save the well, stop it. I guess this is a much smaller explosion compared to what could be. I'm pretty sure this is a half-blown capacitor now. Measuring the parallel resistance. Oh, it's well over 11 mega ohm now. Well, the good thing is that the plates are not shorted, so it should still be able to capacitate. The capacitance now is only around 420 microfarad. Dropped way down from the original 2200 microfarad. And the ESR now is 1.1 ohms, over 10 times what it was before. I mean, it takes a lot of talent to be able to half break a capacitor after how many minutes now? So it is still a 420 microfarad capacitor, but it is capacitating much less than before.
Still not a ward!
The lower capacitance and higher ESR is a problem for almost every power supply where the circuit takes the input energy and pulses the energy into the output. And the capacitor's duty is to absorb those pulses and create a constant output, like a switching inverter or a full bridge rectifier. Here I have a full bridge rectifier with its output hooked to a capacitor and powered from an auto transformer, so we can provide a safe lower AC voltage. We just have to always reduce your supply's voltage before hooking your circuit up to it. So here is the rectified DC voltage with a 100 microfarad capacitor. If I connect a resistor to it as a load, we see it is rippled because during the off periods of the diodes, the capacitor discharges into the resistor trying to keep the voltage up until the next wave of input charges it back up. But if I connect a smaller 10 microfarad capacitor to my circuit, let alone the higher ESR, with the same load, the capacitor discharges so far it can reset circuits constantly. So anytime you see a bulged capacitor, you should replace it with preferably better parameters so they won't degrade the same. Well, I did have a problem with this wall adapter here, which supplies to all my security cameras, and all my cameras were turning on and off. I cut it open and lo and behold, it was a bulged capacitor. I replaced the capacitor with a higher rating capacitor and it's been working since. Now that we know all this, let's repair a broken power adapter together. This also doesn't output voltage. Looking at the circuit capacitors, they all look fine. So I guess we are stuck with 100 other possibilities. Let's plug it in and measure the output voltage. There is nothing. Is there a burn mark on this? Always disconnect power before touching a circuit. Always make sure the circuit's high voltage capacitors are discharged before touching the circuit. Just weld it. Okay, so there are a few input filter components, the rectifier and its capacitor. Let's measure the voltages. Around 115 volt AC input, around 160 volt rectified DC. So all seems good there. Must be the controller circuit. They are using OB2269. I found the datasheet of the chip. Why does it even say confidential if it is available to public? So this control chip, powered by the rectified voltage, provides a PWM signal to this MOSFET that switches the primary of this transformer, creating a smaller output voltage here that is rectified into DC. The output voltage is sensed through an optocoupler back to the chip so it can tune the PWM duty cycle to fine-tune the output voltage. For some reason the supply voltage to the chip is 0. I wonder. Ah, look, the chip supply line is shorted to ground, which means the control chip is broken. It didn't die a natural bulging death, you know. This was my raising desk's power adapter and died while I was swinging my high voltage magic wand around. Some good size arcs jump from this thing, eh? Zap you! Zap you! Oh, apparently I killed electronics in my adjustable table. No problem, replacing this chip is no problem for me. We just need to find the replacement. It's nowhere to be found except Amazon, where I can get 10 pieces for $11 and receive it after a month. I just need one of them though. Maybe I should get 100 pieces for $22 and throw 99 of them into garbage. But that single one will be 22 cents. A brand new wall adapter there is like $20. So I save $9 if I just replace the part, waiting for a month, spending my own time. It's just sad that all these perfectly good components have to go into the garbage. Well, not for me. I shall keep this in a bin of potentially useful parts, potentially never use it, so after my decease, my descendants would have to deal with the horde of garbage I shall collect over years and send me their curses to add kindling to the fire I'm burning in. Thank you for watching.